many properties of matrices which are based on many definitions of matrices or types of matrices. They're based on their properties. First, what is a singular matrix? Please answer. What is a single?
Matrix with all elements 1.
No.
Determinant is 0.
Yes. Singular matrix is matrix whose determinant is 0. If that A is 0, then A is a singular matrix. All right. Next. Do you know this? If A square is equal to A, then what is A called? Does anybody know? If A square is equal to A, what is this matrix called? A is a square matrix, of course. If A square is equal to A, let's see some chat message.
Identity matrix.
Idempotent matrix. It is not necessary. Identity matrix will satisfy this. Identity matrix will satisfy this. It is called as idempotent matrix. So if A square is equal to I, then A is called. Does anybody know this? Let us see. I get an answer. Yes, involutory matrix. Correct. Correct. Involutory matrix. Involutory matrix. Next, if A power n is 0, where n is the least positive integer satisfying this condition. What is the condition? A power n is 0. That means, suppose A power 4 is 0, but A square, A cube are not zeros. Then what is such a matrix called? Anybody? Let us see. Good. Good. This is called as nilpotent matrix. Nilpotent matrix of index n. Nilpotent matrix of index n. So these are some definitions based on products. This is first one is based on determinant. Second, third, and fourth are based on products. From here, the properties are extremely important for us. What is a symmetric matrix? Anybody? When is a matrix called as symmetric?
If a transpose of A is equal to AC.
Pardon?
if the transpose of a matrix is the matrix itself.
Yes, very good. Very good. A transpose is equal to A. If A transpose is equal to A, then it is a symmetric matrix. Then what is a skew symmetric matrix?
When A transpose equal to minus S.
Very good. A transpose is equal to minus A. Okay. Then what is an orthogonal matrix? What is an orthogonal matrix? Anyone? These are very important orthogonal matrices. A into A transpose is equal to A transpose into A is equal to I. That means product of a matrix with its transpose will give you I. That is an orthogonal matrix, which implies you can multiply A inverse both sides. You will get A transpose is equal to A inverse. A matrix whose transpose is equal to its inverse is an orthogonal matrix. And it so happens that, if you take the determinants of A and A transpose should be reciprocal to each other. And in general, they will be equal to 1. Because if you take determinant of A into determinant of A transpose is determinant of I, which is 1. So determinant of A into determinant of A transpose is equal to 1. So determinant of A transpose should be the reciprocal of the determinant of A. All right. In general, for some particular matrices, there will be 1. They will be identically equal to 1. So this is an orthogonal matrix. Very important. Next, did you hear the matrix by the name Hermitian? What's a Hermitian matrix? Just like we have a symmetric matrix, all right? If matrix consists of complex numbers, as elements, then the conjugate transpose of the matrix is the matrix itself. Example I'll give you. So let us say A is having elements 1, 5, 3 in the diagonal, 1 plus I and 1 minus I, 2 plus 3I, 2 minus 3I, 4I and minus 4I here. So this is the matrix. Okay, this is the first row, first column, second column, third column. Now A conjugate is replace the elements by their conjugates. So 1 remains 1. This becomes 1 minus I. Conjugate of 1 plus I is 1 minus I. Conjugate of 2 plus 3i is 2 minus 3i. Conjugate of 1 minus I is 1 plus I. Conjugate of 5 is 5. Conjugate of 4i is minus 4i. 2 plus 3i plus 4i, 3. So this is A conjugate. Now you take the transpose of A conjugate. A conjugate transpose. Now this becomes, the row becomes column and the columns become rows. So the first row becomes the first column. 1 minus I, 2 minus 3i. The second row becomes the second column. 1 plus I, 5 minus 4i. Then 2 plus 3i, 4i and 3. What is this? This is the original matrix. This is the original matrix. So this conjugate, A conjugate transpose, is written by the operation A theta. A conjugate transpose is A. Okay, we write A raised to theta means it is conjugate transpose. This is a notation, standard notation. Such, just like A transpose is equal to A is symmetric. A conjugate transpose is equal to A is Hermitian. Okay, this is called as Hermitian. Next is Skew Hermitian. Skew Hermitian. Okay, A conjugate transpose is equal to minus A. This is Skew Hermitian. Symmetric, skew symmetric. Hermitian, skew Hermitian. The difference is these are Hermitian, skew Hermitian. They have complex numbers as their elements. That's all. And then you have orthogonal. Corresponding to orthogonal is unitary. Symmetric, skew symmetric, orthogonal. Hermitian, skew Hermitian, unitary. What is a unitary matrix? A conjugate transpose times A is A times A conjugate transpose is equal to I. Okay, so A conjugate transpose is equal to A inverse. A conjugate transpose is equal to A inverse. So this is unitary matrix.